So when we discuss the idea of being able to understand coverage rates, um, being able to understand how much materials we're going to need, it's important for us to be able to, one, accurately understand how products are diluted. One of the things that I included in the Google Classroom last week was information on dilution ratios. So as a refresher this morning, we're going to look at some of that information on dilution ratios. We'll begin with that. Once we cover the dilution ratios, we'll get into coverage rates and understand how much material. So we want to focus in specifically today on the amount of chemicals we would need for the type of project we were doing. So for example, we were stripping a floor. If we were using chemical stripper, how much stripper would we need? How much floor finish would we need? So those are coverage rates. Give me just 1 second. So we'll break that down. I'm going to pull up my whiteboard and share that with you guys, and we'll start to look at that. Let me also open up our Google Classroom.
Hey, Dave, is there a part in the book where speaks on this coverage rate and all?
Yes, it's a good question. So in your book, let me pull up my folder here.
I know I saw it, I just couldn't find it. I was just looking for
Yeah,
it.
so coverage rates is covered for you guys on, let's see here, page number 16. In the top left-hand column there of page 16 is information on coverage rates. So let's start first with just the idea of dilutions, and let me share my screen with you on this one. So when we start looking at dilution ratios, I sent this out as a homework and assignment, but I will go through and explain it a little bit again, and we'll actually go through this process. So the instructions explain that a cleaning agent's dilution ratio indicates how much water must be mixed with the product to get the optimum cleaning power. Ratios are expressed as a 1 to X, whatever that second number is, or 1 unit of cleaning agent to X units of water. So for example, as it's written here, a 1 to 64 dilution is written with 1, okay, a colon, and then 64. That means 1 part cleaning agent should be mixed with 64 parts of water for the product to work as the manufacturer has intended it. So when we see these dilution ratios written as this, as 1 to 64, a lot of times that doesn't help us to measure it out. If I'm using a measuring cup, well, how much is a 1 to 64 ratio? To determine how many ounces per gallon of water that we're going to need, we first need to understand a very simple thing. So, and that is understanding volume. And that is in volume that each of the container size that we use in terms such as gallon, in a gallon, there's 128 ounces in a gallon. Doesn't matter what that liquid is. So that's the one that we're going to most commonly refer to is terms of ounces and gallons. And an ounce is the basic unit of measure that we will deal with. So if a manufacturer states that a chemical is to be used at 2 ounces per gallon of water, what they're saying is it's 2 parts, okay, or 2 ounces of chemical to 128 parts of water. It is written as 2 to 128. However, when we see ratios, they're not written like that. They're always written with a 1 first, the lowest unit of measure. So how do we get 1 to x when we have a ratio of 2 to 128? Everybody with me so far on this?
Yes.
Okay. What I need you to do me a favor so that I make sure I've got everybody with me. I'd like you to, in your response portion on the bottom of your screen, click the thumbs up. Okay. So if you're understanding where I'm at right now, give me a thumbs up. Or you can visually give me a thumbs up like this. Mark, Nelson, Steve, okay, come on. Maria, you're not quite sure, so I'm going to help you. By the way, we use a saying in this class. We're like the Marines, no Marine left behind. Okay, so we all succeed together. All right, how about some of the others? Tyler, are you getting this? Got it? Amon, are you with me here? Amon? Okay, I'll come back to you.
Yes, I did a thumbs up.
Okay, I didn't see your thumbs up.
It's on the chat thing.
Oh, you know what? Instead of putting it in the chat, because I can't see the chat when I'm in this, you'll just, there we go. Cool. How about you, Christina?
I don't think my computer lets me do a thumbs up.
Okay. So you grasping this concept where we're at?
Yeah.
Okay.
Yes.
Tony, Don, we good?
Yeah, I put a thumbs up in the reactions.
Okay.
Yeah, I did the reactions too.
Yeah, for some reason I didn't see everybody, so I'm not sure why they did that. Okay. So Maria, I'm going to help you just real quick back. Where did I lose you at? And you're muted. You're muted, Maria.
When it's 1 to 64, it's not divided.
No, we're not dividing anything yet.
Oh, okay.
All this is reading. This is not 1 divided by 64. It means 1 to 64. So
Okay.
an example of that, and I'm going to use a ratio in this class. Okay. In
Okay.
this class, there are a total of 9 students, I believe, 3, 6, 10 of you. Okay. So there are 3 women to 7 men in this class. That's the ratio.
Uh-huh.
There's a total of 10 people in the class, but there's 3
Yes.
women to 7 men. We could also say there's a ratio of 1 teacher to 10 students. That's also a ratio.
1 to 10.
Yep, it's a 1 to 10.
Okay.
So does that make sense when we're talking about parts? Right now in the Zoom meeting, there's 11 parts. There's 11
Okay.
people on here, and I represent 1 part. That's the teacher. The other 10 of you are students.
Okay.
Okay, so that's what we're
Okay.
talking about is in dilutions or in ratios, all we're talking about is parts. And in this case, in chemicals, those parts are represented, instead of saying students, they're ounces. Each part is an ounce. Now, the reason why we would need to understand this 128 is because in a lot of what we deal with when we buy a chemical, we're not buying it by the ounce, we're buying it by the gallon, which is 128 ounces. So that's where we get that 128 from. Okay. So once we know this, we have, in this case, we were told 2 ounces per gallon of water, which is basically 2 to 128. How do we break that down to a smaller number to get this smaller ratio? Well, what we do is we divide both sides of the ratio evenly. This is when we do a division. In this case, because 2 is the lower of the number, we'll take 2 and divide it into 128. So 2 divided by 2 is 1, and 2 into 128 is 64. So now we have a ratio of 1 to 64. So when we see something that says a chemical is stated to be used 2 ounces per gallon of water, it has a dilution ratio of 1 to 64. I want you to be able to know that, because when you look at it, you should be able to quickly know when you see 1 to 64, that means 2 ounces per gallon. Very simple. So part of your assignment this week, and actually we'll take a little bit of time today to work on this, where you guys could do it in an independent study part. We'll take about 10 minutes to do a couple of these for you. So Maria, you understanding that now? Okay. All right, then let's move on to the next portion of this, because that covers dilutions and how we get the ratio. The second part of this is how to dilute a chemical to fill a container. That's a little bit more difficult. So how do we do this? I actually wrote it out as a formula for you guys to help you to understand how to dilute a chemical to fill a container. To be able to do that, you first have to identify each of the following. You need to know the container size. You need to know the dilution ratio, which is what we just did. And by knowing that dilution ratio, then you'll be able to identify the total parts. So the way this formula works is we take the container size, divide it by the total parts, and that equals how much each part is. So for example, let's use the example that was in our test on the ISSA basic course. The question in that test asked if we had a 32-ounce bottle and using a dilution ratio of 1 to 4, how many ounces of chemical and how many ounces of water would we need? How do we determine that? Well, first, we know that the container size is 32 ounce. That's what it says. It says, let's say we make a 32-ounce bottle with a 1 to 4 dilution. So next we know the dilution ratio is 1 to 4. Because we know that dilution ratio is 1 to 4, we can determine that the total parts is 5 parts, right? 1 part chemical, 4 parts water, a total of 5 parts. So we put that into our formula. Okay, CS is the container size, that's 32 ounce. TP or total parts is 5. So 32 divided by 5 is 6.4. So in this bottle, each part equals 6.4 ounces. So we would put in 6.4 ounces of chemical and 25.6 ounces of water. That right there is how we do the math for this. Mark, question.
When you get a decimal, is it rounding or use the decimal?
Okay.
I mean, that's where I always get lost.
Yeah. So if we are doing this for a test, use the decimal because you want to be accurate. However, if you are going to be doing this in dealing with actual measurements, then we would round up. And remember the principles of rounding. If it's less than 0.5, we round down. If it's more than 0.5, we round up. So in this case, it would actually be 6 ounces of chemical and 26 ounces of water would be a fair amount, because you're not going to measure 0.4 ounces. That's just going to be impossible. So it's easier just to go with rounding when we're actually measuring. You're going to be close enough, but I will tell you this. If you are dealing with a chemical mixing station that actually mixes it for you, it is precisely measured. So they actually will go to the thousandth in their percentages as they're looking at it, because they create a hole within a little metering tip that precisely measures how much chemical will go through that. So I don't even know how they do that, but I just know that that hole opening in the metering tip is based on that dilution ratio or that percentage. So they need to know exactly. But for our purposes, we round it. So let's do one more example. We have a 1:7 dilution ratio for a 32-ounce bottle. So what's the container size? Who can help me?
32 ounce.
32 ounce, right? The dilution ratio is what?
1:7.
1:7. So how many parts are there, Eduardo?
8.
8 parts. So we do the math. We take the size of the bottle, 32 ounce. We divide it by 8, and the answer is 4. So we have 4 ounces of chemical and 28 ounces of water to fill that spray bottle. So this all making sense now? We're good. Here's what I want you guys to do. This is your assignment for this week, is to do this. There will be one other assignment that I will be giving you as you complete this, and that will be to do the coverage rates, because we're going to move on to that next. A lot of this was done in the last lesson, but it's just a good refresher for those of you who haven't done it in a little while. So that'll help you. All right, so now we're going to move over to my whiteboard as we do this math. Let me share my screen here. All right. So you guys all should be able to see my whiteboard here. If you guys will reference this information on page 16 of your book, this will help you. And we're going to use these formulas, and we're going to understand roughly, if we had to do a chemical stripper on the project we did the other day on Saturday, we're going to figure out how much stripper we would need to use. So the way this is worked out is coverage rate. That's what we're referring to. Coverage rate is the total amount of square footage, okay, divided by the coverage rate. So, for example, the square footage that we had for doing those 2 rooms on Saturday was approximately, and I'm going to round this, 400 square feet that we did. Now, if you notice in the instructions, who can tell me what the stripper coverage rate is? How much does stripper cover?
83 square feet.
83 total square feet. Yep. So if stripper covers 83 square feet and we had 400 square feet of area to do, break out your calculators. Should have told everybody, make sure you have your calculators. You'll notice it is 4.8, okay? And in this case, we're dealing with gallons, 4.8 gallons of product. Now, what we have to understand here is that 4.8 gallons, that is of diluted stripper. Okay? 4.8 gallons of diluted stripper. Because we're only talking about how much product we put on the floor. Our book doesn't cover this, but I do want to cover it for you. How much actual chemical would I need to be able to do that? Well, now that I know that I needed 4.8 gallons of product, right? It helps to know how much product will my stripper make. So in the course of this, most strippers, and not all, have a dilution rate of 1 to 4. 1 gallon of stripper will make 4 to 4 gallons of water makes how much total product? 1 to 4, how much can I make with that?
5.
5. Thank you, Eduardo. 5 parts, right? So if I have 1 gallon of stripper, I add 4 gallons of water, I can make a total of 5 gallons of stripper. What was my amount of product I needed for that job?
4.8.
Yep. So would I have enough stripper with 1 gallon?
Yeah.
Yeah, I would, huh? I'd have just a little left over. And it's better to estimate a little high. This area, we do not have to be exactly precise. We just want to make sure we have more. We just don't want to need to have too much more. So for example, if I had a dilution rate on my stripper of a 1 to 2, that means it would make 3 parts, right? Now, is 1 gallon going to be enough for that job? Nope. It's likely that I'm going to need 2 gallons, more likely about 1.5 gallons. But having 2 gallons, I'm going to be okay. I can't buy stripper in a 1/2 gallon. So when I'm estimating, I'm going to round up all the time. So knowing how much product I need in the coverage rate is going to help me to determine how much product to buy. And I'm always going to buy where I can round up. So I'm going to look at those dilution rates on the bottle to see how much will it make. Is it a 1 to 4? Is it a 1 to 2? A 1 to 3? Some strippers, I worked with a chemical company. We had a stripper that had a 1 to 8 ratio. Okay. So 1 gallon is more than going to cover my job. And that's all I need to buy for that job. So that when we look at how much materials we're going to need, that's one of the things we have to determine is how much product do I need to purchase. So what I will give you in a homework assignment is I will give you some square footages. You're going to use this as the standard, okay? Now, for the purpose of our lessons, I'm going to tell you this in the industry. 83 square feet coverage rate for stripper seems very, very conservative. I typically work with a number more like 100 to 150, but every chemical manufacturer is different. For the purpose of our lessons, for your project, for everything, we're going to use that number of 83 square feet for the coverage rate for floor stripper. That will become our standard for this course. So floor stripper has a coverage rate of 83 gallons of solution needed. Okay, or 83 square feet that we could cover with a gallon. That's the proper way to say that. Everybody understanding where I'm at?
Yes.
We're all good?
Yes.
Okay. So that is to cover how much stripper we're going to need. Let's go back to our 400 square feet. And you guys noticed that we used less than 1/2 gallon, or right around 1/2 gallon of product the other day for the 2 coats. When we're dealing with floor finish also has a coverage rate. And a lot of manufacturers have a pretty broad range. Some will tell you as low as 1,500 square feet per gallon. Others will go as high as 3,000 is their coverage rate. So the industry standard, again, according to our book, for floor finish, the coverage rate is 2,500 square feet, is what 1 gallon would cover. Okay, but that is 1 coat of product. How many coats did we put on Saturday? Who remembers? Yep, Nelson, you're right, 2 coats. So we had 400 square feet. We need to divide that 400, okay, by 2,500. So using your calculator, take 400 and divide it by 2,500. And what is the math for us? You're muted, Nelson.
That's 16.
0.16.
0.16.
Yep. Okay. So 0.16 of a gallon would be enough to put 1 coat on that floor. We did 2 coats. So we'll multiply that by the amount of coats. And that would have been, so we'll, first of all, we got 0.16. We multiply it times the 2 coats we did. And it should have been about 0.32, which is pretty close to what we covered. We used about a little less than half of a gallon for that. So we were applying it pretty close to what the industry is. Again, every floor finish is going to be a little different. So I'm using an industry standard, not what that manufacturer states. That manufacturer may have stated 2,000 square feet or 1,500. So they know their product. And I would recommend, when you guys are determining this, for the purpose of our projects and everything, we will use this 2,500 square feet as our average number or our standard. But when you guys are out in the working world, I want you to be aware of and read the label on your product. Make sure you know what that product says it'll cover, because there's some interesting factors that will come into play. The amount of solids that's left behind plays a factor. Okay, and that will affect the coverage rate. So for example, a product that has very low solids, maybe 15 or 16% solids, will leave a lot less material or finish behind than a product that has a solids content of 25 or 28%. Therefore, they have a much better coverage rate because they're leaving a lot more material. Okay, so those factors come into play. Just make sure you know your coverage rates according to the manufacturer. Also, to determine how much product you're going to need, you need to figure out how many coats you're going to put on that floor. So in a case of you guys working with a job, a lot of times your customer will dictate how much coats they want. They will tell you, we expect that you will put on 3 coats of floor finish or 4 coats of floor finish every time you're scrub and recoat. Okay, then I'm going to make sure my customer gets what they're paying for. And I'm going to make sure I have a product that has a really good coverage rate so I can keep my costs down on materials. So those are a couple factors that come into play. So what we've just determined in this was, in this case, stripper how to determine its coverage rate, and then here, floor finish. So in the case of our job on Saturday, if we were using chemical stripper, we would have needed 1 gallon of concentrated stripper. Everybody understand that? Because we needed to make up 4.8 gallons of diluted stripper. So 1 gallon at a 1-to-4 rate would have been enough. And we would have needed less than a gallon of floor finish. So if I was buying materials for that job, I would bring a gallon of finish and a gallon of stripper, and I would add all the materials I needed, which is what I had. I had a gallon of stripper. I had a half gallon of floor finish, which I knew was enough for us to be able to complete the job to get a couple coats of finish on there. And you noticed that floor looked fine. Now, keep in mind, we were just scrubbing and recoating. If we were stripping a floor, our coats instead of 2 coats would have likely been 5 or 6 coats we would want to put on the floor. And the reason being, we've taken everything off the floor. There is nothing there. And in that case, then we absolutely need to make sure we have enough to fill in all the voids, all the nooks and crannies, and a lot of that is going to soak into the floor. So what we will do, and this is where you guys will be able to help each other out a little bit in group sessions. You guys will have an assignment. We'll do that assignment on Wednesday. I'm going to give you the individual assignments to work on dilution ratios today. And that will, you get that completed. But then I'll give you the assignment on coverage rates. How much material would I need for this job using, and I'm going to say in this, using industry standards. 83 square feet for stripper, 2,500 square feet for floor finish. Customer requires, and I'll put the amount of coats that's needed. Your job will be able to determine how much product should I get for that job. You guys see how this really is going to benefit you in being able to estimate your materials?
Yes.
Okay, good. Okay. So what we're going to do now is take a minute to be able to look at something, and then we're going to kind of switch gears a little bit. First of all, let me stop my screen share. And in switching gears, we're going to look at how this is going to affect something that is in relation to your final project. So I started to build together. How many of you guys have looked in the classroom today and saw your class assignment for the final project? Who's seen that? Nelson, you saw it. Stephen? Okay. So let me show everybody that assignment and how that's going to break down. Don, you saw that? Good. All right. So in your final project assignment, you saw that we broke apart the groups, and now we have assigned into our first group, Dawn, Tony, Nelson, Christina, and Tyler. You guys are going to be working with an elementary school. And as part of it, these are the 5 areas in the school you guys are going to need to determine. Okay. So you're going to begin your homework of starting to figure out what's going on in that school. And that's why I wanted you to start putting some thought behind it. Because as we do this, you're going to need to determine how much product you will need. This is going to help with your assignment. So for example, in your school, how many classrooms do you have in an elementary school? How big is a classroom? What type of flooring do they have? How many windows? All those things are factored in when we start to determine how much time it's going to take us to clean, how much time it'll need for some of our project work, and how much materials we're going to need. In the restrooms, how many restrooms are there? Within a restroom, how many fixtures? How much square footage? What type of flooring? In this particular part, the restrooms, you'll start working on that portion here in a few weeks. But you can start to kind of get some ideas by looking at school sites. And one of the reasons why I broke up the groups and changed it a little bit on Saturday is I wanted an even amount of existing school custodians and people who are not working in custodial. So now we have 3 custodians and 2 who are not working in custodial in each team. So in your team, you have, we just said that was Tyler and Antonio. So in your guys' case, you know, Tyler, you might remember from the school you went to some details, but rely a little bit upon the custodians to be able to help you to determine how much of this stuff. Okay. The office space, you're going to have to worry about how much cleaning of office space. We're going to have a multi-purpose room that you have to clean and a library you have to clean. Within your final project, each one of you in the group is going to be responsible for a different area. Now, as a team, you'll help each other out, okay? But it'll be your responsibility to present the cleaning process for that area. Whether you're assigned the restrooms, the office space, the multipurpose room, the library, whatever it is, that's your assignment, okay? So within this assignment that has been posted now, you guys will be able to start looking at that. In just a minute, we'll go into breakout rooms and you guys will start to be able to kind of discuss this as a team. Now, in the next group, you guys are cleaning a medical building. So in this case, we have our group being Amon, Stephen, Mark, Eduardo, and Maria. You guys actually have an advantage for cleaning a medical building. The roles are a little bit reversed here. Stephen, if those of you guys don't know, was an optometrist, correct, Stephen?
Yes.
So Stephen actually has the experience of dealing with a medical office building as far as knowing how it is set up. You haven't cleaned it yet, but he knows the setup of an office in it. And he can be able to bring some of those ideas of what they had in their eye doctor. Mark, your project that you did in the last class, you'll be able to pull some of that as well to help your teammates. So as much as Eduardo and Maria and Amon, you guys have the cleaning experience, these guys have a little bit of the knowledge of the background of some of this stuff just from their assignments or what they've done. So it'll be a nice experience. In your case, the 5 areas I want to see in yours: office space, restrooms, patient rooms, common areas, and lobby. Common areas would refer to the hallways, okay? Or if it has, for example, if you were dealing with a dialysis facility, they have one large treatment area. Then they have individual patient rooms for specialty treatment. So in that might be considered a common area because a lot of people, and that's going to get the most traffic. In both of your groups, you are to have one area that is specifically going to require floor finish on it. So for example, yours might be your common areas in the medical building, whereas in the school, that could be the multi-purpose room, okay? Or it could be dealing with, I wouldn't say in the restrooms, but it might be in a classroom. That part of the classroom has VCT in part of that, or vinyl that you're going to need to wax periodically. So that's going to play a factor in how much you're going to need. And you guys will have to determine that and tell me. So I'm not telling you which one it has to be, but it does need to be practical according to what it is. So, for example, I would not see a medical building where they put VCT in the office area. Mark.
Uh, So the place can be as big or small as we choose to, as long as it has those rooms, correct?
Yeah, and I want it to be practical. So, for example, a medical office that has 2 patient rooms, a little too small. I want to see it have enough of that so that you guys can do some numbers with it. So let's be reasonable with it. At the same time, and that's a good question because with a school site, an elementary school, you have some elementary schools that only have 250, 300 students in it. Others have 800 or 900 students. So let's use a little bit of an average, say a school that might have about 500 or so students, 400 or 500, kind of an average size. And you guys know a little bit about that. You could be able to give thoughts and input as a group and decide for yourselves what that'll be. I'm not so worried about the size of it as long as all these areas are covered. That way you guys get the experience of coming up with a plan for that. So unlike in the basic class, we're building our plan now, just a week into class. One, because this class moves much faster. But number 2, as you guys are determining stuff, you're going to need to start to figure things out fairly quickly as you're doing it and applying some of this practical knowledge into a real world situation. So from that standpoint, it'll help you to start to determine how much products I'm going to need, how much am I going to need to do these jobs. So what we're going to do, it is 9:44 right now. You guys have that information in the Google Classroom. The screen share is open so anybody could share. I'm going to break you up in your breakout rooms and we will go to 10 a.m. with information. You guys can start to just discuss these areas and where you might have VCT in that area so that you can start to think about what that would look like for your projects. So let me assign the breakout rooms. And while you guys are in your breakout rooms, I will be working on the next portion of our lesson today. So let me start assigning these. Maria, there you go. Good.
Emilio, what time you have to go back?
The other group doesn't want to leave.
Well, that's because we got this. We got this.
I know you do. I think the fun part of this that I was excited about for all the groups is that you guys are going to be able to take it the next level. You know, you got the basics. Now it's okay. How does this apply when I have to be able to figure out a job? You know, my boss has said, we need to clean this area. What is it going to take? Not just in the procedures, but now obviously also what is everything I need? You all had to figure out before in the basic class, what was the equipment, what materials, what supplies did I need? Now it's how much supplies. And on Wednesday, because we're actually doing well on this class, Wednesday we're going to go off of the book for an hour of our class, and we are going to get into determining how much time does it take. So we'll be using some ISSA standards. So part of today's class, we were also going to focus in on a review of the work we did on Saturday. And we already did this, but most of you turned in your homework assignment. And in turning in your homework assignment, we identified what was the equipment, materials, supplies, and procedures we would use. I want to review that briefly because I want to share with you guys part of what I'm looking for so that you can then take this to the next level. So I'm going to pull out two of these and share them with you guys because I've got a couple really strong ones. So Tony and Mark did great job on some of this, and I appreciate your guys' work. And everybody, thank you guys for getting your assignments turned in. You know, I know some of you had also had to work over the weekend, so that's understandable. You know, get it to me in the next day. But here's what I was looking for and what I saw. This was from Tony. He identified the equipment. He had his rotary machine. He had 3 mop buckets with ringers. Okay. Now, Tony, I will mention here, you have mops listed as an equipment. Mops are to be listed as materials. Okay. Putty knife, dust mop, broom, scraper, sponge, squeegee. So all those are great. He also listed PPE, safety shoes or boots, eye protection. I would have added gloves there, and then stripping pads. Mark did something very similar. He listed swing buffer, wet dry vacuum, which obviously we absolutely need that with extension cord. Good catch on that, Mark. I love that. When I saw that, I was laughing last night going, yep, that was exactly it. Mop bucket, ringer and mop handle, scraper, putty knife, broom dustpan, dust mop handle, doodle bug with long handle, wet floor signs or cones, garbage can, and squeegee. Excellent with all the equipment. And then the materials. He had the PPE listed, gloves, eye protection, stripping shoes, the surface prep pad, mop heads, doodle bug pad, dust mop head, towels, duct tape or painter's tape, garbage bags, and caution tape. So really good list of that. And then the chemicals. And it's an interesting thing. So you mentioned about water, and I don't know if it was in your guys' class last week or I had the other class ask me this same question. Is water considered a chemical in my listing of supplies? You never have to list water because we only think of the things we have to bring with us. Water should be there. Now, that being said,
It was a 50-50 shot, so I put it down.
if there's no water there, don't do the job. And one thing that's not taught in this class, but I will always encourage you to do, go check out the information or look at the site before you start doing a project. Always a good idea to do. So he had the solvent government remover, aerosol stripper for doing edges, floor finish. What I didn't see was floor stripper, but in this case, I think you were referring to what we did, which we did chemical free, right?
That's correct. I think I mentioned that at the top of the title. So
Let's see here. Probably did. Floor stripping. Yep, chemical free stripping. Excellent. So one of the things I want you all to understand what we're looking for is in putting these procedures together, think in terms of in a leadership role, how would you instruct somebody else, your coworker? And what would you want as instructions for you in going about doing this job? So that's what we look for is being able to have it where not only do we outline those things, but we also break it apart in an understandable fashion so everybody can understand. So like in the case of what Tony did, he listed his equipment, materials, and supplies first, whereas Mark listed it last. It really doesn't matter. There's not a one way or the other as far as that goes, as long as it's all there.
well, I
Then
merged two PDFs and I didn't know how to separate it, so I just went with it. So
you did fine. And in all honesty, guys, the other thing I want you to understand is I give you a lot of information ahead of time so that you can build this and put it together. Plus, you could go out on the internet and find some of these things and compare it to what you're learning in the book and what we're discussing in class. There are going to be tips and tricks of the trade that you can learn by picking up from other people. That's part of the learning process, and part of our role, within learning this trade, we're going to learn the basic procedures, but you're going to really refine that as you get the experience. And we had a lot of good experience. Dawn and Amon, really, you guys did a great job of taking the lead. Christina, thank you with your help with that as well. So all of you guys, I'm appreciating that. Mark, your question.
well, touch on that. That's who I, appreciate the help of the people that were there. The other showing me and telling me how to do things and watching and listening to you guys. Because Eduardo, Amon, listen to all you guys, gave me all these tips to figure this out. Reading the book is one thing, but when you're doing hands-on, that sticks better. So,
Yes,
but thank you to all of you that helped me out yesterday or the other day.
and in reality, as we go back to when we outlined this course, we never had intended for either of the course to be a straight bookwork type of class. That is not the way we had intended this. We had to do the previous class and even your guys' class from last year in the spring, Dawn and Amon and Stephen, all you guys, where we finished up the class with no hands-on, where we had to do it bookwork wise. Not exactly the way we want to do it. The good news is, as you guys saw, we're now coming back to hands-on sessions. So we'll do these classes, but then we're going to go back and do hands-on. And that's what really helps. Tony.
Yeah, it kind of got me thinking when you were saying, if a machine is broken, you have to pivot, you have to learn that you have to do it more of a manual way. And it just got me more thinking about watching the two rooms and walking up and down that hallway and, knowing that you just have to be flexible. Not every environment is going to be totally stocked, totally set up, all the equipment you need, all the product you need. I mean, the real world is I got to go to 3 stock rooms to try to find what I need.
Yeah.
And hope that I have it, you know?
Yeah. And even if you have it all, tools break, equipment breaks down,
Yeah.
things happen in the job. And so you have to adapt.
Yeah.
What you want to try and avoid is having to stop in the middle of a job to go get something, to go get a piece of equipment. There are going to be times where you have to. As I mentioned, if we were cleaning a multi-purpose room and our floor scrubbers broke down, we're dead in the water. There's no way we're doing a multi-purpose room without equipment. Same thing is true, and here's another example. Electricity goes out. You, in a small area, you might be able to do it with Doodlebug and do it all manually. But if you're doing a large area, so for example, I could do that lounge room without electricity with using mop buckets and so forth and scrub and recoat it. But again, I couldn't do a large area. I wouldn't even try to do room 10 without having electricity in a machine because it would be just very labor intensive. So much bigger than what we saw in that area that had the vending machines. We're going to need that. So again, you adjust and you accommodate for that. And that's part of the experience of going beyond just the basic, is learning how to be adaptable. So I loved what I saw here, even including steps of gathering the equipment needed, prepping the area. So Amon, you did a great job, and I wanted to thank you for that, of helping to prep, because you kind of got it started. And Christina, you were over there taping down plastic and getting things prepped for your guys' area. That helps a lot because we were preparing the transition areas and making sure we were ready. And even with all that, we think of the wet floor signs, caution tape, and or cones. We were the ones who did the work. We all knew those floors were wet, but inevitably we still had some incidents, right? And that happens. That's where, even with existing workers, if we would have put up maybe some caution tape, it's just a reminder, oh, don't do that. Don't go in that area. It's not ready yet. So those are things that I'm reminded of as a teacher, to teach those little details. So every time I do a project, I'm learning, you know what, remember to teach this. Remember to add this into it so that we have everything we need. Okay. You guys outlined details as far as mopping of floors, all those details. And that's what I'm looking for, is spell it out for somebody else who is doing the work. So as you guys do your next projects, that will help you to really take it to the next level with that. Okay. Does that make sense? So one of the things I wanted to do now is just take a minute to discuss what some of the variables could be, and also some questions you guys had. Did any of you go home and afterwards maybe have some thoughts about what we did, or questions, concerns, anything along those lines? So then
I was just thinking about I was just thinking about, like you just said, prepping the transitional areas. It kind of went fast. I mean, even though it seemed like it was going slow, it really it went super fast, even though we were waiting for some stuff to dry out. But as we started, we're like, all right, let's grab this, let's grab that. All of a sudden the tools showed up, we're plugging things in, and then boom, we just started,
Yeah.
So yeah, no, kind of looking at it from like different project perspective, when you're a homeowner and you're having to do a lot of your own DIY and you're going to paint a room, it takes forever to paint a room. That's why people hate painting,
Yeah.
But a lot of that same fundamental it went into some of this.
Yes.
Yeah.
Yep, absolutely. Preparation is key to it. By doing those prep steps, having everything there, we gathered as much as we could from supply closet stuff we brought in, and that way we were ready to go. And yes, we still did need to pivot, adjust on the situation with the wet vac, but we did a real good job of doing that. You guys were seamless in adjusting to that, and we still got it done in a very efficient manner. And I allocate more time than is needed because I want to make sure, we're not rushing through it just to get a job done. In teaching you, my goal is that everybody gets comfortable with being able to do some of this stuff. I think there was a couple people still didn't get a late finish, so I apologize for that, but I will make sure there's some opportunities. We're going to have some opportunities to do some additional work. So, and that'll help. Now, let's just kind of adjust this or modify what we're talking about and apply it now into your scenarios of your projects. In the case of your projects, as you're looking at it, and I'm going to start with the school. Did you guys decide as a school which area was going to end up being the VCT area?
Yes, the multi-purpose room.
Multi-purpose, okay. Okay, so Dawn, I'm going to ask you to help your team out. Do you guys have a rough idea now of how big a multi-purpose room would be?
I'm thinking about 3,000 square feet. I'm not really quite sure.
Okay, so average is between 3 and 5. So
Okay, that's what I thought.
Yep, and I want to address this as well. Does everybody know how to determine square footage? How to measure, come up with square footage for an area?
Let's take a refresher course.
All right, let's do a refresher. This one's a pretty simple one. Generally speaking, area is a basic formula. It's length times width. Now if you take, for example, a large multi-purpose room, measure one wall and the other and multiply those together, and that'll give you your square footage. Mark asked me a good question in our basic class. For example, in patient rooms in a medical building, we have a square footage, but does that include or do we exclude the areas where there is things placed in the way? For example, a patient table, a cabinet that might be there with a sink. Do we exclude those areas? If they're very large, we might, but most of the time we don't, because it's better for us to estimate over and allow for some variables that could occur than for us to be so tight with our measurements that we measure it too tight, and as a result, we might be short on materials and as well short on time. So from that standpoint, I always include those areas in my measurements, and pretty much that's the standard in the industry. We include them. We just figure they add a challenge. For example, in a medical building, they add the challenge that you have to work around these obstacles, so it becomes much slower. And here's an example, and you guys are going to see this when we do the numbers on Wednesday, when we're starting to talk about how much time it takes. If you are doing a large multi-purpose room, what piece of equipment would you use to scrub and recoat that floor?
Auto scrubber?
Absolutely. Good job, Tony. Auto scrubber is far more effective to do a large floor than to use a swing buffer and a wet dry vac. Now, I'll be honest. I remember I told you I did a large, it was about 3,000 square feet that I did in one day by myself, about killed myself because I used a swing buffer and a wet dry vac and a few mop buckets, but I was the one changing the mop buckets. I was running back and forth, squeegeeing it, sucking it up, and I was just doing a scrub and recoat. I just needed to scrub it clean, put a couple coats down. Same process, SPP pad. I didn't use chemical stripper, but it takes time. An auto scrubber is great. So your production rate, how much time it takes to do it, is much higher when I'm doing an area like that in comparison to what we did on Saturday. On Saturday, we were doing small areas, going from room to room. So it's a much slower process for doing that. And in those areas, I definitely need to use just a simple wet dry vac and a swing buffer. So those played into the factors as well. So you guys have identified a multi-purpose room that should improve your time there. Here's the other area that it's going to improve on. You guys saw how much time it takes for floor finish to dry. We were drying in about 20 to 30 minutes easily. Okay. If we were doing a multi-purpose room, and let's just use that 3,000 square feet, by the time I get from the area I started laying finish to the area that I walk out and finish, where I started is possibly close to dry already. So my time that I'm waiting in between coats is much faster, especially if I have multiple entrances. Now, challenge would be is if I only have one entrance to that multi-purpose room, it's going to be a little challenging because I got to wait for the last area I did to dry first, to be finished drying. But if I could be able to come back around and start where I began, my time in between, even though the dry time of the finish is the same, because it took me maybe 15 minutes to lay the finish, I may only have a 10 to 15 minute time in between that I have to wait to go back and start again. So my whole production time increases, including the wait time I'm sitting around waiting for finish to dry. Now, Mark, go ahead.
You wouldn't go back in and start at the beginning while you're waiting for the time to dry at the end, seeing that the first part is dry. Would you overlap it that way? I mean, is that what you're kind of saying?
Yeah. So, for example, if I have a room that I start on the far end and I get to the end that I leave out of, that is still drying. I can go back over here and start again up here. I'm going to make sure I give it enough time, but if it takes me 15 minutes to lay that, I'm going to be good. Don, your thought?
Would you recommend kind of going in a different direction? So say you start long ways. So now, in order to make sure that the floor gets covered, at no spots were missed, you would then start another way?
So I'd
That
always
makes
start
sense.
at the same spot, but I would change the direction.
Direction, that's what I meant
Yes,
to
I absolutely.
say.
Yep. And another good point along the lines of this is I'm also going to stagger my coats in the form of the
Yeah.
coats up next to the edge. So if my first coat is along the edge, my second coat, I'm going to keep out away from that edge a little bit. And it depends on the area it's at. In a multi-purpose room, I may be as far out as a foot away from the base. Whereas in an area that's a small area like we just did, I may only be about 4 to 6 inches out away from the base in how I do it. The other thing I look at in doing that, just like you said, I will alternate, I'll change the path. So if I'll still start at the same spot, but if I'm going north and south, I'll turn around and go in east to west direction in laying my finish. So, and one of the things I will caution against, until you get to the point where you're very comfortable laying finish, and you've been laying finish for quite a while, try not to go way out with your swing of your mop as you're going out. I watch guys, and I've seen guys who are really skilled at this. They never miss anything, and they could cover a large swath, but they're laying finish 5 days a week, year round. Those guys are great at doing it. They will also typically not use a microfiber. They'll use a rayon finish mop because they can swing it better. They have a better flow with it. They'll put a lot more material on it as well. So they've gotten familiar with it and more comfortable. Nelson.
So when we do the MP room, we're gonna do it. We're gonna do that as a team.
As far as
Um,
the procedures,
yes.
nope, you're going to assign one person to develop that. Now, as a team, you'll have input on it. Everybody will have input on all the areas, but one person will be the one to pull it all together and write out those procedures and write out all the equipment and stuff. So each person in your team is going to have an area that they'll be responsible for writing that out. And then you guys will help each other out on that. Mark.
Yeah, I'm just curious, in regards to their situation, that room, when determining manpower wise, and does equipment that you use as an auto scrubber change the manpower hours, or is it
Absolutely
based off the
does.
square footage?
Yeah, so one of the great things, and you'll see this as we go into this on Wednesday, the ISSA cleaning times, which is a time standard that has been developed by the industry, bases it on literally the equipment you're using. So it will even change the size of the machine. For example, a 20-inch auto scrubber and a 32-inch auto scrubber are going to have much different production rates. So today we covered dilution rates. We talked about coverage rates. Now we're going to talk about production rate on Wednesday. And that production rate changes based on two factors: amount of obstacles, and number two, the size of the equipment. And usually the amount of obstacles and the size of the room will dictate the equipment that's able to use. And that will change those variables. It's a significant swing. You guys will see that as we go into it. So let me wrap up with the school on the MP room. What I'm going to, a way that you guys can learn, and this is for everybody, how much square footage. There's two ways to be able to measure it if you don't have a measuring tape and you want to cheat. They're a little bit more difficult, but I will tell you the tricks. If it's VCT on the floor, VCT is a standard 12-inch by 12-inch. Count the amount of tiles on the wall one way, the amount the other, and that's gonna, you multiply that, that'll give you your square footage, because each tile is 1 foot square. Okay, so that's one trick. The other trick that also can be used is using ceiling tiles. So if they have a drop ceiling in an area, you can use the ceiling tiles. Those ceiling tiles measure 2 foot in width and 4 foot in length. So if you're doing that, and you'll see this a lot of times in classrooms, you can measure the ceiling tiles in the classroom. If they are a rectangular one, they're 2 by 4. If they're square, they're 2 by 2. Count your ceiling tiles and then use those numbers. So if it is laid out in such a way that the longer section has the longer part of the ceiling tile, the 4 foot width, and let's say there is 20 of those, you'd multiply 20 times 4 feet for the length of that tile. That'll give you 80 feet. And then you turn around and count the tiles going the shorter section, and maybe that's another 20, but that's only 2 foot in width. So now we have 40 by 80. Nelson.
Now, let's say you work, let's say for me, I work at a older school that have wood they don't have ceiling tile.
So if you don't have ceiling tiles and you don't have the VCT on the floor, then and it's sheet vinyl, for example, that you're doing, you need to take a measuring wheel or a measuring tape to measure it. Those are 2 shortcuts that I've learned over close to 30 years of doing this, but they only apply if you have those 2 variables. Okay, that makes sense? So shortcuts are always just that. They're just a shortcut. A lot of times, and I've worked with a lot of salespeople, a salesperson doesn't always have their measuring tape out when they're going in, and a customer will at the last minute say, hey, this room, how much is it going to take for me to put down or get this stripped? Off the top of your head, you're trying to figure it out. So we use those shortcuts to be able to figure out the square footage and be able to then apply that and give a number. Okay, so that is going to be for your area. In the medical building, okay, with Mark, Steve, Amon, Eduardo, Maria, did you guys determine what area will have a vinyl or resilient floor?
Yeah, so we kind of looked at the lobby area.
Okay.
And the common area is going to be VCT.
Okay.
The patient room is going to be LVT, offices carpet, and more than likely have a hallway in there with a carpet as well.
Okay. So that being said, the common areas, if you think about a lobby, you'll want to kind of come up with an idea of how big is that lobby. Same is going to be true with you said, what was the other common area? The lobby and what else?
The lobby, common area, it's going to be hallway,
Okay.
patient rooms.
Now the patient rooms
bathrooms.
was LVT, right?
LVT, correct.
Yeah.
But the lobby and the common areas were going to be the VCT.
Okay. And that's not uncommon to see a combination because they do a little bit of decoration. So one of the biggest challenges is you will see facilities do stuff like that because architects love to kind of mix and match a lot of different textiles, a lot of different surfaces in a facility, especially in a medical building. So,
well, the main reason was with patient rooms, we can't take out those things. So to strip and wax in there, an obstacle. So easier to clean, easier to sanitize. That's why the LVT went in the patient rooms.
Great idea.
So,
Yep.
Open areas, you can actually work on those. So.
Yep. Plus the open area, that VCT that's in the front lobby, it's a great spot for you guys to maintain and to have where it can have a real nice high gloss. So it can look really crisp. Now here's the difference. In a school, based on your guys' experience, how often do you get to touch the floors as far as putting floor finish on, scrub and recoat or strip?
Once a year.
Once a year. Yep.
Yep, I agree.
Yeah, once a year or during the winter break.
You might be able to do a scrub and recoat. Here's what I'm going to propose for you guys. I'm going to propose that you guys are going to do a once a year strip and wax. Okay. So yours is going to be more aggressive. You're going to be completely stripping it down. And then even though it will be chemical free, I want to see that you guys scrub that down, which means more passes with the SPP. You want to get as much of that finish off as possible. The other thing is, I'd like to see that you guys on that MP room at the winter break go in and do something. And that could be a couple different options. It could be just a quick light scrub and put a coat down, or it could be just a good deep clean and buffing the floors out. So that could be an option and using something for that. Don, go ahead.
So we're doing chemical free for the MP. We're not going to calculate
I'd love to
sugar
see you guys do,
ratio.
you know what? Because we'll go with a school site that would allow chemicals, let's do the stripper because I want you guys to get that experience. So let's go with the chemical stripping
Okay.
and the figure that you guys are doing it complete. And with that case, I would say I'd like to see 6 coats of finish put on it so that it will last through the school year.
Okay.
Okay. All right. For your medical building, what I want to see is that you guys would have 1 strip and wax being done. And reality is, in a medical building, that could last 3 years, 4 years before you have to strip and wax again. It's that good. But I'd also like to see a program where you guys are buffing the floors once a month. Okay. So that'll be part of your guys' program. And I would say at the 6-month mark, you would probably come in and just do a light scrub and recoat with an SPP pad. So that'll be part of your requirements on your floor. All right. So the plan for as we move forward, I want you guys to finish reading over this chapter this week. That is your homework for this week. On Wednesday, we will be covering information about the labor portion of this. And then we're going to get into other types of flooring. We will spend an hour on Wednesday on polished concrete. So I'm going to go through the polished concrete workshop that I just recently did and walk you through that. Then on Friday, we'll come back and we'll finish on other types of floors. There are some challenges. If you guys look at your books, in the back of your book, one of the great tools that I love that they put in here is hard surface floor care problems. And it's a troubleshooting chart, basically. So one of the things that we will do in our session this week, and we'll include it into Friday, is troubleshooting some problems that could occur on a floor and you guys identifying how you would fix that problem. Okay, what is the solution? So I will be putting together the problems. You guys need to include that in your reading this week, how you're going to troubleshoot it. Because as a group, and I'll be doing it as a breakout room, all right? So your breakout room will have the troubleshooting. So that'll be part of the fun project in your breakout rooms. It will be specific to your type of building in an MP room or in the medical building. So we'll identify those. The other thing interesting here now, if you guys look over this, you notice all the other types of flooring. There is the quarry tile, the wood floors are listed. I'm not expecting anybody to have wood floors in their building. Although a lot of schools use wood floors, most wood floors in schools are reserved to gymnasiums where basketball is played. In some of those cases, those gymnasiums do serve as multi-purpose rooms, but most schools have gone away from the idea of an MP room having wood floors, mainly because we're also using it for things like lunches. We're using it for things like assemblies. They use it for everything. That's why it's called a multi-purpose room. Whereas a gymnasium, a lot of the schools will use mainly in the high school for the PE department. They might use it for volleyball and basketball and sports events, but they don't use it a lot for assemblies. They don't use it ever hardly for as a cafeteria area. So if they do, it's only because out of necessity. So our focus will be on the resilient portion, but on Friday we will also cover these other kinds of floors just so you're familiar with them, because I want you to be familiar with how do I maintain those? What am I going to do with that kind of floor? So, and I'm working on picking up a couple samples of some stone material so I can show you guys some of the challenges and give you an idea of some of the problems we might run into on these floors and how to resolve those problems. Okay. So, homework assignment for the week: read the chapter, make sure you finish this chapter, do the dilution ratio problems that is done. If you have not turned in your homework assignment on the stripping procedures, get that turned in to me. And that will be it for today's class. I am going to keep the classroom open for about 20 minutes to help anybody that had any problems with loading their homework. Overall, good job with you, what you guys did on getting that loaded and getting it to me. Really good job as a class. So, all right, I'm going to stop the share and I'll end the video recording.
Hey, Dave.
Yes, sir.
The